So, good evening, everyone. We are on project number 4, day 1. Our topic for project number 4 is plant growth. And what we are going to do here is the classification for the plant growth data. So, as per the data set available, it is related for predicting plant growth stages or milestones based upon various environmental and management factors. Okay, we are having environment details along with other factor too, and we need to identify whether with these environment and other factors, if given to the plant, what happens to the growth of it. So in environmental and the factors in the data such as soil, sunlight, water frequency, fertilizer, temperature, humidity, they are responsible for growth of the plant. Okay, what fertilizer, what soil, how much sunlight, what is the frequency of water, how much you have to give, what kind of fertilizer you are going to apply, what should be the humidity. So if these things are in a appropriate numbers, there will be a growth in the plant. Else, the adverse conditions will affect the plant growth. Okay, so we are having a data with the features as I already told: soil type, the composition of soil where plants are cultivated, sunlight hours, the amount of intensity of sunlight the plants receive, water frequency at which the plants are watered, fertilizer type, the kind of fertilizer applied as a nutrient, temperature, okay, under which the plants are growing. So every plant and this production, they are having obviously some proportion to all these things. Not every plant require the same soil, neither the same sunlight, neither the frequency same, neither the fertilizer same, neither the temperature same, neither the humidity same. Okay, in on Earth we are having different environmental conditions and different places, and according to these factors, the growth is there. Okay, the target variable is growth milestone. That means the growth stage or a milestone achieved by the plant. Okay, so if I talk more about the soil type, composition, and the characteristic of the soil, such as if the soil is having clay, sandy, loamy, or peat. Different types of soils impact the water retention, nutrient, root penetration. They play major role because we have to harvest the plant in the soil only. The growth of the plant is from this only soil. Okay, then comes how the photosynthesis do perform. For that, we require sunlight also because the plant has to prepare their food. So, for preparation of the food, sunlight is required. So, how much duration, what is the intensity of sunlight will receive per day? That also is important for the growth of the plant. Okay, if you keep the plant in dark, then obviously it will affect the growth. Water frequency, how much it required. Okay, in terms of days per week or times you are giving the water to the plant. Okay, what is the schedule so that the plant can absorb the nutrient and maintain the hydration for healthy development. Fertilizer type, okay, obviously these are the chemical organic components, okay, like nitrogen, phosphorus, potassium, that save the plant from unhealthy things, okay, and they supply the nutrients for the growth, root development, and flowering, everything. Temperature, okay, environmental temperature, what it is required. So sunlight and temperature, there is a sunlight, okay, I think sunlight hours, and at what particular temperature. See, sunlight can be 40-degree also, sunlight can be like less also, but how much temperature, what's the minimum temperature a plant require to survive, to have some good growth, that is what mentioned, ambient temperature, okay, to perform its metabolic process like germination, respiration, transpiration, all these things. Okay, so that is required. Okay, fine. And then humidity, amount of moisture present in the air, typically expressed in the percentage. How much moisture is there? So humidity can influence the plant's water loss through transpiration and affect the susceptibility to disease such as mold or mildew. Okay, so presence of water components in the environment, that is what the humidity is. It is also affecting. And this is the growth milestone. This is the target variable, indicating the stage or the significant events of the plant life cycle, such as germination, vegetative growth, flowering, fruiting. Okay, the plants, okay, if it's a flower, so flower will given. If it is a fruit, so fruit will be given, and it depends. Okay, so that's what we have to predict. Okay, so what could be the problem statement available to us in this particular project? On the basis of these factors, because they are having so much variation, these components are not in your hand. Sunlight is not in your hand, temperature is not in your hand, humidity is not in your hand, water frequency you can provide, you can give water to the plants, soil you can, okay, you can harvest, and that's something which you can do, okay, and fertilizers you can give from your side. So in this, environmental condition is not your in your hand, rest you can manage. Okay, so understanding how these variables interact to affect the growth, that's a challenge, because one is in your hand and one is not in your hand. Okay, and we want farmers to grow plants, healthy plants. How you are going to help them? There are other issues also, but not covered in the data set currently, because it is talking about the greenhouse managers, and there are many things. Okay, pollution, and there are many things that are not covered in the data, but there are certain other factors also. That's a problem statement. Okay, so we are going to develop the classification model for it. Okay, so any doubt, please let me know about it if you have ping for any question. Yeah. Okay, so data set is good. Okay, and yes, we have many things to learn over this particular data set. Okay, so aim is to develop a classification model that predict the growth of the plant by facing these challenges. And what we are going to do, we very well know. Let me share my entire screen now. I will show you the data set also. Okay, and we'll be moving ahead with the implementation of this particular data also. Okay, so let me share the screen. Okay, fine. We got in the data, okay, how you are going to approach. Okay, I guess if you are having an issue in the project that is related to the approach, you should be clear with the problem statement I already told. You should be aware of the steps to be used for the model till the model development, prediction, everything. Okay, you very well know the basic steps are, okay, sir, you are available with many different types of features. Different types of features are available. Okay, we are going to perform the pre-processing of it. We are going to take the complete EDA and the visualizations, all that we have to take into the consideration. Okay, and then we'll proceed for the modeling part. Okay, in context of the data, in context of the problem statement, you have to perform these steps. Okay, that's what you have to decide. Okay, so one question, we can apply econometrics model and optimization techniques. Economics model. Okay, so what models you are expecting here in this particular case? Econometrics. What is the expectation? Econometrics, if you are saying, what is the expectation related to it? You are available with the data. Let me show you. Here it is. This is your data set. Okay, features I have explained, and that's what your data means. Okay, see, here it is. You are having the soil type, you are having the sunlight, you are having the water frequency, fertilizer, temperature, everything. That's what you are having. And the target is like 0 1. That's a growth milestone. In econometrics, what you expect here? Is that related to this biological growth and the development for a plant? Any factor you want to include? You want to perform any feature engineering to produce, to have some new features? That's what I did in the project. I will show you. So analysis will be according to the requirement, according to the aim, according to the problem statement only. That's how you have to do the analysis. Okay, so I am having a soil type. Yes. Yes. Okay. So Mr. Pawan said okay. So this is my data in which I am having soil type, loam, sandy. These are the clay. Okay, these are the soil available to me. I am having sunlight hours also for that particular location. 5.194. This much sunlight hours are available for us. Okay. Water frequency bi-weekly, weekly, daily. How, okay? How you are providing the water to the plant? Are you providing by twice in a week, once in a week, daily? You are providing water to the plant. That is present in the water frequency. Fertilizer you are having chemical, organic. तो खाद जो होती है, that's what we say in Hindi. तो जो आप you are providing to the plant, so it can be like a chemicals, nitrogen, phosphorus, and potassium, and etc. Organic components can also be there. Okay, so chemical components, organic components, some don't require anything. None. You are not providing any fertilizer to them. This is the temperature. Okay, and here is the humidity in percentage. How much fraction of water droplets are present in the environment? This is humidity, and this is how the impact growth 0 1 0 1 and so on. So it's a binary classification. So temperature, humidity, moisture, whatever you want to say, sunlight hours, these are environmental factors. Soil type also, I guess, that's a land or how you are growing the plant. There are some things which are dependent, some are not dependent. Okay, you can consider. And water frequency, it's up to you. Okay, as per the requirement, as what the engineering says related to that particular plant. Okay, so that's how you're giving the water to it. Fertilizer, okay, you can, okay, chemical, organic, what you are giving. Okay, and here is the target growth milestone. So how these features are impacting the growth milestone? We can see that all the features are like the impact. All the features are having the impact. We don't have any kind of a feature which is unnecessary, not mandatory. Okay, that we can assume that okay, that's not related to the growth milestone. All the features are related to the growth milestone. Okay, you can see that these are categorical types. Okay, and this is okay categorical. It's continuous. This is also continuous. This is also continuous, and this is discrete 0 1. So continuous, discrete, categorical, all you should notify. Okay, and since it's 0 1, so you will be building, you will be building a classification model. That's what you are going to build, classification model. Okay, that's what your approach should be. Fine. And you are having many classification models in your hand. In the previous session also we have applied those models. All right. So that's what your data is. The problem statement is, the introduction is, aim and everything I have explained here. Okay. So let's approach to the implementation part. This is the implementation. You gave a title, plant growth data, you added your image to it, and here you are taking your necessary libraries what are being required here: numpy, pandas, matplotlib, everything you are taking. Warnings also taking, you're taking your data also for the analysis. Plant growth data. Okay, head and the tail, that means the first 5 rows, last 5 rows you have printed here. Shape also you have printed. Your data is not that much high, it's 193.7. This much rows and 7 columns are available with the data. Okay, and the dataset overview I have already explained here. I also included in your project in this particular notebook. Okay, duplicates, there are nothing. Null values, there are nothing present in the data. Information if you print, okay, I've already told you that there are object types, floating integer values are present in the data. Okay, description is only for the numerical. This is what the description is for the numerical features present in the data. Okay, and here it is the number of unique values present in the data. And then you proceeded ahead for the object types and numerical types present in the data to identify. So these are object types and these are the numerical types. Out of which you can classify categorical, non-categorical, discrete, and continuous. You very well know the approach is same. I keep in every other project so I can explore the data well. This is how I approach. I keep the approach same. Okay, so these are my features present in the data. Okay, so continuous, discrete, and categorical. And you also know that what kind of plots we can make for the categorical, discrete, and continuous. For categorical, I am taking again count plot and the pie plot. So these are the unique values present in these features. These are the value counts present in these features. Okay, and this is the count plot for them. Okay, so soil type, water frequency, and the fertilizer. Count plot, and this is the pie plot for them. The distribution, how much, okay, how much they are giving. So the distribution for all the data which is mentioned here is also like in good proportionate. You don't have to check out that whether there is unbalancing or what. So good proportion we are available with, because I already told in the previous class also, the challenge we do face, the challenge we do face with the data, is type. That means especially if you are having categorical and discrete training features, not target, I'm talking about training feature, then you are having an issue. I have been asked a question just in the opening of the session, sir, real time data, sir, real time data. Okay, if I know how to work on data, I know what kind of feature any kind of data do possess. What kind of feature? That's what I in every analysis I do include this thing only. Discrete, categorical, non-categorical, continuous. Can you tell me anything apart from this? Are you available in your data, whether it is real time, whether it is non-real time? Can you please tell me anything else you are available with the data? Tell me. Just tell me anything else apart from this. Are you available in the data? If you have any other category, any other type, please let me know, which I haven't included in my data set for the analysis. Please let me know. Yes. The issue is, okay, your real time data, okay, may have multiple features. It may have complex values, okay, which will show a challenge for you to interpret. Okay, it may show some challenge for you to, but it's not like that you are very much like, if you do, if you know, if you don't know this thing or know this thing and you can't work. No, you can work on this thing also. If you know this, you can, you should, you will be able to work on this, because the steps for data science and machine learning will be same as what I'm doing right now in this particular project. Only I took my data. Right now I'm doing my EDA part. That also you will do with the EDA part. With this data also you'll do with the EDA part. Visualization I will do with my, you will do here also visualization. You will interpret the correlation. You will interpret the dependencies. Okay. You will interpret duplicate value, null value. Here also you are going to do. Okay. The issue is, again, I'm going to put a mark. The issue in your data is, what I always feel is a challenge is related to the discrete and categorical. These are issues. Okay. These are issues. Why? See, I hope you might have studied. For example, in my data, this is my data. Okay, this is my data. I am having a target as 0 1 0 1. I am having as features x1, x2, x3, and they are discrete and categorical in nature. For example, I am having a category A, B, B, B. Okay, and like this, 0 0 0 1. And this is something, so let's suppose some continuous value, 1.5, 2.5, 3.7, 4.9. So I don't have that much issue with the this continuous. Why? Because see, if you take this data for training, model training, you have to split in train and test. Now what will happen if you split this data in training and the testing? For example, my splitting, I took this data for the training. Okay, I took this data for the training. So this training data will be like 2.5, 3.7, 4.9, 0 0 1, B B B, 1 0 1. Okay, 1 0 1. You can see, okay, this is your target. Somehow what you balance it and you do everything with that. Okay, data balancing, you apply smart and all these things, you balance. Are you able to balance this thing? Are you balancing this thing? Tell me, do you do the balance of features also? You do data balancing for target. Do you balance training features also? Now if you take this data for the training, one thing, if you check in this training data, I am not available with A, but A is present. A is present in the data. In X3 you are available with A also, but its proportion is very less. While training, you picked the data which is having all the B's. You split it 80%, 20%. That particular case, the training, if you are going to train the model with this particular data, the model will have no idea about what is A. Okay. It knows about B, it knows about 0, it knows about 1. And continuous, I don't have any issue. Continuous is the something best, I believe. Because in real world, the question of real time data, real time, which is changing frequently. तो रियल टाइम में ये ज्यादा होता है, दिस वन कंटिन्यूस, और आपको फिर भी टेंशन है. Okay, real time में the most of the people do the projects like for industry, anyone like sales prediction, sir. We are in an industry sales prediction, sir. So the client give us data of sir. These are the products. These are the investment which we did in the products. Okay, and this much sales happened. Okay, investment number one, investment number two, investment number three. This is the sales real time. Okay, you can make real daily basis or something like that. Daily basis, weekly basis, real time data. You got it. So investment is also continuous. This is continuous. This is continuous. Sales is continuous. Okay, तो मेरे पास most of the feature ऐसे वाले, most of the features. But what about this data where the features are, which are features are discrete and the categorical inside and outside you are again having a category, or if you are having not category also regression also, still as many as features you are available here in this particular format challenging. What can I do with that? Should I balance? Shall I have to independently balance this thing and this thing? The entire procedure will be disturbed. So discrete and categorical are always challenging. Continuous is okay. I am happy with that. So that's what the okay. I guess I don't know whether the data scientist people how much they focus upon this particular kind of distribution. Okay, but if you do study, we do study, and we are having both kind of random variables. Random variables. We do have discrete also. We do have continuous also, which shows the distribution of discrete and continuous variables. Okay, for continuous, we do prefer normal distribution. That is the preferred one. In statistics, preferred, continuous, normal. In discrete question mark. You may have binomial, you may have Bernoulli, you may have Poisson, depends. We are least in interaction, I guess. Okay, because discrete tossing of a coin, rolling of a dice, such kind of entries. Okay, continuous kind of data, more appropriate one. Okay, so here when I was checking the distribution, you can see these are the training features. Soil type 33, 34, 32. Water frequency 31, 38, 30. 33, 38, 20, 28. Okay, fine. So I think if I split also, na, I will be getting some good proportion. I will be getting some good proportion of the data. That's what I will be available with. Okay, fine. So this is for categorical visualization. And then I perform the visualization for discrete, that is your milestone 0 and 1. Milestone are balanced in nature, so I don't have to do any data balancing at this particular, okay, for this particular Okay, data. Okay, fine. And then I made the count plot for the discrete two, 97, 96. Okay, and then the pie plot for it. Okay, I made the pie plot for it. Okay, fine. And then I proceeded ahead to make the plot for continuous. Okay, so I made histogram. You can see the distribution now. Okay, this is the plot for histogram, sunlight hours, temperature, and then humidity. None of them are normal. Okay. However, since you are using classification algorithm, so classification algorithm, there is a difference also. Classification and the regression, there is a difference. Classification don't ask for normal distribution. They don't ask. However, they expect standardization, standard. Okay, they do expect standardization of the data. For example, if you are using support vector classifier, it requires standardization, standard data. Okay, but in case of decision tree, random forest, logistic regression, they don't require the standardized. However, I have seen that decision tree, random forest also performed good if you give standard data to them. I've seen practical scenario में. ऐसे they don't demand. Neither logistic regression, that it also don't demand. Only the thing is logistic regression is says that there should be a log of odds relationship between the target and the variable, and no correlation. So this one also, no correlation between the features, among the feature. That's it. And you can go ahead to perform the classification. Okay, all these things, it should be aware for you. You should know about these things. What is the demand? Now here is the distribution. Okay, this distribution plot, histogram, box plot. Here is a box plot. I don't see any outliers present in the data. The data is also like 193 rows, so there is no outlier present in the data. Okay, then okay, box and plot, wall and plot are optional, though I have included in my project. Okay, then categorical versus continuous. That means how much percentage of soil type is related to the sunlight hours. Average. Okay, average. So for loam, the average temperature is 6.41. For sandy, the average temperature is 6.76. For clay, the average temperature is 7.27. These are the average temperatures. Okay, fine. Similarly, for other features also. For soil type, what should be the average temperature? Okay, humidity, average humidity, and water frequency, sunlight hours, all these things. What are the average values? Okay, fine. So this is what we can make in bivariate analysis. Okay, in bivariate analysis, you can make categorical versus continuous. You can also make discrete versus continuous. In bivariate analysis, bar plot. Here also bar plot is preferred. Bar plot. This is what you can make. Okay, fine. So I have built the bar plot for them. Okay, all the bar plots. Average values are shown here. Okay, discrete versus continuous also. Bar plot. Average values. Okay, growth milestone, that is for 0. Sunlight hours 7.02. Average sunlight hours 7.02. For growth, it is 6.63. Average sunlight. Okay, fine. Average sunlight hours. All right, fine. All right, just a second. हाँ हो गया सब. वो तो मैंने बोला ये कार्यक्रम.
तो उनको पूरा समझाया इसलिए बीच में क्लियर किया कि वो
Okay, so this is the bivariate analysis we did here. All right, and then box plot also we can make between categorical to continuous. However, it's not mandatory as such. Bar plot is preferred. You can make box also. You can make wall in also. Okay, they can also be done in the bivariate analysis for categorical versus continuous and discrete versus continuous. That is also fine. Okay, so I made them. I included in my project here, so you can refer to these plots also. Okay, fine. Okay, so here are the plots for them. What you have to analyze in this particular plots or in this particular visuals is in the bar plots. In the bar plots, you should analyze the average requirement of the values of features like sunlight, sunlight, then humidity. Okay, sunlight, humidity, and temperature related to your water, sand. Okay, water, sand, and fertilizer. Okay, how much water needed to be given with respect to this on an average? How much? What should be the sand with respect to the sunlight and all these things, and what fertilizer will related to this thing? So this is how you can this is how you can make it here. Okay, fine. And then you can relate, okay, for each to each. Okay, that's what you can do. Okay, so these details are very much important. Fine. And I have included them, the average values, in my visuals for that. And then what next I did is I found the correlation. So whatever be the numerical columns present in my data, I found the correlation between them, including continuous and discrete. Okay, including continuous, continuous and discrete, I found the correlation between the features. Okay, and I found that there is not specifically any correlation present. Okay, the features are not at all correlated, so that's good for me. That means all the feature I will take in the contribution for the model development. Okay, just very less, 10%, 5%, 12%, 12%. So very less correlation. Okay, in fact, growth milestone is my target only. Okay, so the features are not at all correlated. Okay, again there is one part to be considered, sir. Since you are dealing with supervised, again there's a question. You are dealing with supervised algorithm. In supervised algorithm, you are having the features and you are having the target. Okay, right now what you said, that if you make a correlation matrix between the feature and the target, it means growth was present as a discrete. Okay, so you are available with the continuous features, you are available with discrete also. You find just right now the correlation, and with continuous features it doesn't found any correlation with the target, not as such. See, how is this possible? You can see sunlight hours, temperature, humidity, correlation with the growth milestone. Only this is 12%, this is 5%, this is 13%. So these environmental factors are contributing less to the growth milestones. Or how this is possible? Being as a data person, you have to understand, you have to analyze each and everything. If environmental factors itself are not contributing to the growth, then sir, how this is possible? So then what is the sense of model development, sir? because you are taking supervised, and supervised means relationship between x and y. That means x1 should be in good relation with y, x2 should also be in a good relation with y, x3 should also be in a good relation with y. Huh, not among each other, but with target they should have a good correlation. But right now we are not getting so much in this particular way. In fact, we are having negative values also. If I talk about sunlight hours, and if I talk about the growth milestone, if the sunlight is more, 12% decrease in the growth. Okay. If I'm talking about the temperature, 5% decrease in the growth. If I talk about humidity, 13% decrease in the growth. This is what I'm getting. Okay. So with these only, we are going to proceed ahead. Okay. Also, just check in the histogram. Okay, just check in the histogram. Okay, how is the distribution of data? How much variance we are having for the continuous features? See here. This is the distribution of sunlight. This is the distribution of temperature. This is the distribution of humidity. Now, it has been told that it has been told that if you are having good distribution, if you are having high variance in the data, okay, if you are having high variance, okay, high variance in the data, your model, okay, high variance in the data, that means features which are having high variance, their contribution in the model development is more. Okay, model development contribution, they are more, variance is high. If you see your data, if you see your data here, the distribution of sunlight is from 4 to 10. For your temperature is 15 to 35. For your humidity is also 30 to 80. This was distribution you can see in your data, not so much high, because very high variance we prefer that if you are having a features like this. Okay, if you are having a features like this, x1, x2, x3, some features are having a value 1000, 2000, 3000. Some values are having 10, 20, 15, and like 1, 2, 3. So this feature is having high variance because the points are very, 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 very far away. So they are distributed, highly distributed. So high variance, more contribution in the data, more contribution in your model development with the high variance. Okay, so at least we expect that the threshold will be 5%. At least a feature should have more than 5% of the variance, so that it can contribute to model development. If you are having any feature whose variance is less than the 5%, then its contribution is negligible. This is a technical point. Negligible. If you calculate the variance, var, variance for any of the feature, and if it is variance is less than 5%, its contribution in the model development is very less. ये टेक्निकल है, आपको पता होना चाहिए, you should know. Okay, so there are many things to be included in the analysis, though okay, we take the concrete core parts. Okay, we don't put many things in the code. However, you should know what feature is contributing, what feature is not contributing, and how you are going to achieve the good score with the model development. Okay, so this is the correlation which I'm getting. And after getting the correlation, okay, I am looking forward for the pivot table. That means I took soil, water, fertilizer on the index, and these values here. Okay, these are the values, and I'm taking the mean of them. Okay, so soil type clay, water frequency bi-weekly, chemical fertilizer I'm taking, the growth is zero point 0.6 mean, humidity is mean this thing, sunlight hour is this thing, and temperature is this thing. Okay, so this pivot table is a very good pivot table to talk about the mean values for all with respect to the index values. Okay, the entire table I made it in one go itself. Okay, fine. So here it is talking about that how much clay is contributing daily basis, weekly basis for the growth, and what are the mean values related to it for the humidity, sunlight, and the temperature. Okay, fine. So here is the entire pivot table. Okay, I made some cross tabulation also. One more table, that is the cross tab. So cross tab is for like soil type and the fertilizer. Okay, so this is the soil type clay, loam, and sandy, and this fertilizer chemical none and organic. Organic. So 25 I'm entries for the clay for the chemical, 24 I'm entries having for entries for num, and 18 entries I'm having for the organic. That's what I am having. For loam, I am having 17, 24, and the 21. Okay, so these are the number of values for the respective soil type. Okay, with respect to the chemical, none, and organic in our data set. Okay, I made this plot also, bar plot for cross tabulation. Okay, for clay, loam, and sandy. Okay, whatever be the numbers here, na, that will be displayed here in a stack. This is a stack plot. Okay, this is a stack bar plot. So you can make a bar plot with stacking. So 25, 24, and 18 will be one above the other for the clay. 17, 24, and 21 will be one above the other for loam, and 23, 26, and 15 will be one above other. Okay, that's what we'll be having in the stacked plot. Okay, fine. So I built for this thing also. I made the cross tab for soil type and water frequency also. Same, I made the stacking plot. Then I made the pair plot also for it. So in pair plot, I took the continuous features. Okay. For pair plot, you have to take the continuous features. Okay. And the entire plot will be made in pairs. Okay. This will be made in the pairs. So here you will be having the histogram in the diagonal. Okay. And this is what you are having. You can see humidity versus sunlight scatter plot, humidity versus temperature scatter plot. So you are having the scatter plot and the histogram in the pair plot. So you can make this in one go itself using pair. Okay, taking the features in pair, and you can make the plots for them. Okay, fine. So this is pair plot. Then I decided that can we do some feature engineering for it. Can we do some feature engineering for this particular data? Okay, so soil fertilizer interaction, this is one of the feature I created by considering the soil type and the fertilizer type. So soil and fertilizer, can we have an adapt related to it? Soil and fertilizer, what kind of soil will take what kind of fertilizer? Can we make a feature based upon it? So I made a new feature called as soil fertilizer interaction. Okay, I added these soil type and fertilizer type. Okay, however, I'm not sure what kind of result I'm getting for the soil fertilizer interaction. This is what I'm getting. Okay, the things are clear when I see the output. Loam chemical, sandy organic, loam none, and this thing. So this is the soil and this is the fertilizer used for it. So previously I'm having in different features, different columns. Now I am having in one column itself. So new column I created, soil fertilizer interaction. This is my feature engineering. Okay, what else I can do? Water sunlight interaction. Okay, how much is the sunlight and how much water you are going to give? Okay, so water frequency with sunlight hours. Okay, so where I am having this water frequency and the sunlight hours, here it is, water sunlight interaction. Okay, so water bi-weekly, this is the sunlight interaction. Okay, weekly, this is what. So with underscore, I'm merging these two and creating a new feature. Okay, just try to have some optimized data so I can understand. Here also I took two. Here also I took two in one. Okay, and then uh, temperature humidity index THI, can we found that thing, temperature humidity index. So for that there is a formula to calculate THI, temperature minus 0.55 into 1 minus humidity by 100 into temperature minus 14.5. This is a formula. So I can take THI. So I am having both of them present in my data set. I can find THI, temperature humidity index. I can find. Okay, water adequacy. That means if you are supplying water, if water is available daily to give to the plant, then you are having good quantity of water. Else you are having a scarcity of the water. Okay, so frequency of water, if you are giving daily, then 1, else it is 0 divided by the temperature. This is water adequacy. One more feature I create. Also, base temperature I considered as 10 for the plant growth, for example. So, growth. Okay, I created one more feature, GDD. If the and I applied this thing over the temperature. If your temperature minus base temperature, if your initial temperature minus the base temperature, if it is greater than the base temperature, it is greater than the base temperature. For example, you are having a temperature mentioned in your data 30, and if you are subtracting 10 from the 30, the answer is 20. 20 is greater than the 10. Okay, so it is greater than the 10. So here you are putting it as, what you are putting it as, if x is greater than the base temperature, then return the value of x, else it will be 0. Okay, else it will be 0. So base temperature you can take and you can create a new feature also. All right, so these are some new features which I created, and I can have the fertilizer count also. I have some fertilizers, so I converted them into the counting. So that also we can make fertilizer count. You can see. Okay, fertilizer count. Here it is. Okay, so that is your fertilizer count is related to the group by of fertilizer type. Okay, and we did perform the counting for it. Okay, just count how many fertilizers are there, each and every category, and fill it up. So that is the fertilizer count. Okay, here I calculated the deficiency. Okay, these are few features. There are some features which I haven't got anything. Water surplus deficient, soil quantity score. Okay, they can be ignored. Okay, they can be ignored. Water surplus deficient. These are some additional feature which I created, but not of the use. They are having majorly the null values. Okay, we can ignore it. Stress index, if the temperature is more than 30, humidity is less than 40, stress index. Water soil combo, you can take water soil type frequency. Okay, so water frequency also, soil also, we can take in combination. I took water in combination with temperature. I can take water in combination with soil also. We can take all three in a combination too. This is just an idea. This is just an idea I took to create some new features as a part of feature engineering. Okay, so somehow what I felt to keep this new features in my mind. The point is when I found that the environmental features are least correlated with the target, 0 or 1. Okay, so I took these things in combination to create new feature. Just a hope that maybe if I can use them ahead, so I can get some good model development. Just a hope. Okay, because the relationship only shows 15%, 13%, or 5% related to the environment. Okay, fine, but I am expecting something more, and since this is a biological and a plant growth project, so I suppose that there should be more contribution correlation with the target, but it's not showing that much. Okay, so I did some feature engineering here. Okay, and then I printed the value for it. Okay, so the next thing which we have to see is either the features which I created will take these features, will consider this feature for the model development, or if you think that are they giving the overfitting in the model, so we have to drop them also, or we are already available with these features, existing features, will create the dummies, will take the numerical values, will put them into the models, classification model, machine learning, deep learning, both we are going to put them, and we'll try to identify what contribution they are giving. So this is something which we have to do ahead. Okay, so my next class will be on the model development. Okay, and I'm also looking forward to deploy this model also over the Streamlit. That's what I'm thinking. That will do the model development and quickly will do the deployment also on the Streamlit. It's possible. Okay, it's possible. I will do the deployment also. Okay, because one day I think as per the request came that kindly take for time series problem. Okay, as per the real data. Okay, as per the real data, one day for the time series, so I'll pick up this thing. Okay, for the real data analytics, one time series problem. Okay, so I think that will be helpful or easy for you to interpret ahead. Fine, that's what I'm planning. Okay, so tomorrow we'll do the model development for this. Okay, I'll look out for the Streamlit deployment too. Okay, fine. All right, let me stop presenting. Let me stop recording also.